CosmoQuest Astro Office Hours. I'm your host, Dr. Matthew Richardson, and I was, of course, in the audience with everyone else watching Pamela give her. Let's mute my background there. All right, that's better. Give the Daily Space news update, and as always, it was amazing. And quite frankly, it's a little bit intimidating following up after her. she's great. So, hi everybody. Hi Peter. Hi Skeptic Sai. Hi Susie. Hi Larry. Hey Paranor. Guys, welcome to today's stream. So, actually in preparation for a meeting that I'll be having with Pamela very soon, I'm going to be working on generating some values from my incidence angle analysis code and actually recording those values. That way, if she has any questions, we can quickly work through my code to make sure that that's not the problem. So to kind of explain what's going on here, incidence angle analysis is related to the work that our citizen scientists are doing with the Moon Mapper project. We've requested for our citizen scientists to look at a bunch of images of the lunar surface and identify craters, that is, identify their positions and diameters. The plan is to see if the incidence angle on the lunar surface, that is, how sunlight, the angle at which sunlight is reflecting on the lunar surface, to see if that affects how our citizen scientists are identifying the craters. A part of that task of being able to see exactly how the incidence angle affects our users is being able to determine which images that we have of the lunar surface overlap one another. To give a little bit more of a background on that, we have multiple images, as I stated earlier, and some of these images image the same location on the lunar surface, but at different incidence angle. And so my analysis code that I have here in front of you in the upper portion of the screen, all written in C++, is attempting to be able to identify those images that overlap at different incidence angle. However, it's having a little bit of difficulty in actually identifying the overlapping images. It identifies overlapping images, but it doesn't identify the region in which they overlap correctly. And so I'm trying to fix that, and right now I'm just going to be generating some values on the screen, and I'm going to be recording those values for a meeting that I'm going to have with Pamela either sometime today or tomorrow, or sometime this week. So the incidence angle is being determined by the Lunar Reconnaissance Orbiter, which is a satellite that's currently orbiting the moon, taking images of its surface. The exact math as to how it does it, I can't tell you. I don't know the exact math of how it actually calculates the angle at which sunlight's coming in. I'm going to quickly pop out the chat, that way I can be able to monitor everyone's comments while I'm doing what I'm doing here. And you're not going to be able to fully see everything I'm doing because I'm recording some of these values and I'm using a calculator on my computer, but let's see. I think it's everything after this. I'm going to want to be able to do some calculations to make sure everything's working properly. Let's put that there. All right, so we're going to start off with image sets. So along with looking at some values that are stored in our database, I'm going to print to screen what the algorithm is extracting from our database and what calculations it's making, and then manually do the calculations myself, just to make sure that everything's coming out correctly. And then record that information into a little notepad that I have here on my computer. All right. So I want to be able to first start off with making sure that the algorithm is correctly identifying the location of these images as seen by the coordinate system that I've established within my code. And I've done this before, but I've never actually recorded the values, and in general they looked right, but this time I'm just going to go through every single image to ensure that that's the case. Let's actually just run a for loop. It's not that many global images that we have in our database. That font looks really small. Let's increase the font a little bit. All right. So image sets. All right. See you later, Paranor. Let's see. All right. So image sets I dot to make this a little bit easier, I probably should also pull up all the functions that so Emacs include image sets. So the information I'm going to want to pull up are the maximum and minimum latitudes, the maximum and minimum longitudes. And this is just to make sure, of course, that the data that I'm getting from the database is correct, or at least it's retrieving that information correctly. And really all I'm going to do is just copy and paste it into a text editor. See that. Yeah, science is fun. It is. It's even more fun when things are working correctly. Let's see. Image. I have a few more things I want to be able to actually output to the screen. Let's also get the physical height and width. This information is important as well. And so kind of what I'm doing right now is that we have 26, um, 26 global images. I'll name them as that. 26 global images that essentially correspond to 26 LRO images taken from um, the LRO image archive. And so what I'm doing is making sure that the values in our database are correct for these global images. Specifically, the maximum and minimum latitude as well as the maximum and minimum longitude, and determining if the physical heights and widths, which I'm calculating based off of the angular change in latitude, converting that from units of degrees to units of radians, and then multiplying it times a constant that I've set for the lunar radius, which is how I'm calculating, in this case, if I'm doing the angular change in latitude, I'm calculating the physical height, basically just using the arc length formula. And I'm doing the exact same thing, calculating the physical width of the image using the longitude, the angular change in the longitude, and then I'm using the arc length formula to calculate the physical width. Where the arc length formula is just, if you have a sphere, you take the radius of the sphere, or if you have a circle actually, but you could do the exact same thing on a sphere. A sphere is just a bunch of infinite, like circles together, but in many different angles. But if you take the angular difference in the latitude, for example, and you convert, if it's in units of degrees, convert that to units of radians, and multiply it times the radius of the moon, in this case, you can determine the physical distance um, that the angular difference corresponds to, which is exactly what I'm doing with this get physical height and get physical width functions. I need to add these as well. But yeah, I'm figuring that it's better that I actually record this information somewhere versus in the meeting that I'm going to have with Pamela. If she asks me a question, I'm like, well, yeah, it works. It's better to be able to show that it actually works as well. So, and I have visualizations as well, but sometimes it's just best to just put the numbers and just look at the numbers directly. Every time I eat barbecue, I eat so much that the radius of my circle always grows a lot. But some barbecue definitely does sound good right now. All right, so that's that. Physical. What other functions that I might need? I'll also want to know exactly what values I'm getting for the vertical and horizontal resolutions. And after all of this, I can actually just exit the program and make sure that the numbers are looking good by calculating them manually. All right, so I think I have everything I need here. So maximum latitude, minimum latitude. I should put some spaces in between here so that the numbers don't just all run together. Maximum longitude, minimum longitude, physical height. Okay. Oh wait, I need one more thing. We got derailed by food. No problem talking about food, guys. In all honesty, during these streams, my mind is always split between work and food because it is lunchtime for me right now. So there's one more thing I'm going to need actually, beyond like the physical height and width. I'm going to need the number of pixels. So I need to get the width and height as well of these images. And let's put this in an order that makes sense. So the get height function, then I'm going to change that to get width. All right. So far, so good. Now I'm just going to go ahead and compile this and then run it. All right. And hopefully it compiles okay. It should. Oh, is that a warning? It's one warning. Oh, that is a lot. What's going on here? I'm going to need to check my cout statement there to see what's going on. This is going to be a lot easier if I do this. So all I'm doing is just reordering a few things to make sure that there's no errors with my cout statement because the computer is telling me that there's at least one error or one problem with it. All right, let's check the syntax. Cout, that looks good. This looks good. I'm not seeing any issues here. See what happens this time around. Unused parameters, I don't care about those. Ha! So one of these, these two, I forgot to properly request access to. Oh, and I want horizontal actually. I'm happy I saw that. So it was a syntax issue. So that's been corrected. This should be good to go now. All right. Let's go ahead and clear the screen and run the algorithm. The name of the algorithm is incidence angle analysis, and it accepts one input, the LROC auxiliary data.dat file, which essentially stores all of the incidence angles for each of the 26 global images we have in our database. So I'll run that. And eventually it should show all the information I want to output to the screen. And you know what? I forgot one thing that's going to make this a little bit clearer. The image names. That way I can identify which image I'm looking at. All right. And so after this, I can go ahead and start actually verifying the math is correct. So, you know what? I'm going to add that actually. Let's go ahead and add that information. So, it's always good to have a second or third or as many pair of eyes as you can get to make sure your calculations are coming out right. So I have this text edit window, so I could add this as well. Let's see. So we're going to go ahead and could change the font size in a minute. Let's put it right here. That is extra squished. Oops, not that one. This one. Here we go. All right. So first things first, I need to go ahead and check. Let's actually go ahead and increase the font size for this as well. I'm going to slightly move some things around here. Please do excuse all the formatting that I'm doing here. I want to be able to make sure that everyone can see what I'm saying. Okay. It should be a little bit better now. All right. So I have, there we go. So let's go ahead and check the first image, M1092156991LE, which is actually, so all the images that we have, the 26 LRO images we have, they all come from the narrow angle camera system aboard the Lunar Reconnaissance Orbiter. And this particular camera system actually has two cameras, the left frame and the right frame. And so images that they kind of have similar image IDs. For example, the very first two images we're seeing in the terminal at the bottom of the screen, the M109 image. At the very end of the image ID, you might see either LE or RE, where the LE corresponds to the left frame and the RE corresponds to the right frame. So these images have been taken simultaneously. An image, a region of the lunar surface, in which the images are like right there. They probably even overlap a little bit, actually. All right, so I have all this information. I need to be able to now manually calculate So the very first thing I should probably do is verify that it's actually extracting the heights and widths and the angular information correctly. So I can easily do that just by going over to our database. It's actually on a copy of it's on my computer. Let's see, select star from, in this case, the image sets table. Your name equals, I'm just going to go back. I'm going to copy and paste this name, the image ID name. So the very first thing I'm going to do, of course, is make sure that the information that's being extracted is correct. So my columns are ordered such that the second column should end up giving me the image's height. The third column should give me the image's width. So 8599 is the image height. 4089 is the image width. And so it is copying that information correctly, as I can see here. The next thing I want to look at are the maximum and minimum latitude values for the image. 26.21, 26.09 are the maximum and minimum latitudes respectively. 26.21, 26.09, that's correct. 3.71, 3.63 are the maximum and minimum longitude values. That's correct. And then the information that follows in these last four columns are actually calculations that are being made internally within the algorithm. And if I'm remembering correctly, let me just actually go in here. Actually, I don't need to actually rely on my memory. I could just look directly at it. These should be the physical height, physical width, the horizontal and vertical resolutions, pixel resolutions, that is. So with the physical height calculation, it requires that I take the angular. It requires that I take the number of pixels along a dimension, and multiply it times a pixel resolution. All right, so basically the physical height is the product of the vertical pixel resolution, and the number of pixels along the y dimension. So the very first thing I'd want to do is make sure that the horizontal and vertical resolutions are correct. Oh, I've just been talking and I haven't been looking at the comments. I am so sorry. So I'm currently working on some analysis code that I've written to analyze some data that's been taken by CosmoQuest citizen scientists. The data that they've been working on are images of the lunar surface, of the moon's surface, in which we've requested the citizen scientists to identify craters. That is, identify the crater's position as well as their location. In order for me to do the analysis, though, I need to be able to make sure that I can establish a coordinate system within my analysis code that can correctly identify how the images are, one, oriented, as well as their relative positions to one another. And so right now what I'm working on is making sure that my analysis code can do that correctly. And right now I've written everything in C++. Thank you, Peter, for actually answering that. All right, so horizontal and vertical resolutions. The very first thing, of course, I'm going to want to do is make sure that that calculation is being done correctly. So we'll start with the horizontal resolution, which is the 7th column. And I'll just quickly highlight this one. So we're going to start with this value. So to calculate this value, I need to first get the angular difference in longitude. And so to calculate that angular difference, and this might be best, of course, if you guys can actually still, again, see what I'm doing. So let's actually add one more window, a calculator. And where is it? It's interesting, it's not actually showing up. I see terminal, OBS. Huh. Maybe there's another way I can get it to show up. Browser, display capture, no game, image, media, scene, text, video, window capture. Well, it seems that it's unable to actually capture an image of my calculator. All right, well, you're not going to be able to actually see me do the calculations. But basically, I could just walk through it with you guys. So for this particular, let's slightly move this window. I need to make sure my workspace looks a little bit better than this. Let's try doing this. Hopefully it maintains the, it's a little bit better. All right. So the very first thing I'm going to do is take the angular difference between the maximum and minimum longitude, which for this particular image corresponds to 3.71 and 3.63. So 3.71 minus 3.63, that gives me an angular difference of 0.08 degrees. It's important that I note that it's in degrees because to calculate the arc length, or the physical or the pixel, the horizontal pixel resolution in this case, I need to be able to take the horizontal arc length and divide it by the number of pixels along the horizontal axis. So 3.71 minus 3.63 is the angular difference in degrees. Multiply this times pi over 180 degrees, which converts it to units of radians. And so now I need to multiply times the radius of the moon. And within my analysis code, I have that somewhere actually. Let's see. Here. So I found this value online. And I've set the radius of the moon to be a constant, even though it does change as a function, I think, of latitude. All right, so copy that. It's in units of meters, which means my pixel resolution is going to be in units of meters per pixel. So I can go back here, go back to my calculator and plug that value in. Which actually is going to give me the which is actually going to give me the physical width of the image. And so the value that I'm getting here is 2,425.86 and some more numbers, which seems to agree. So it seems to agree with that actually. 0.87, 0.87. Yeah, that's right. And so now I can divide this by the number of pixels along this dimension, which is 4,089. And I get a pixel resolution, a horizontal pixel resolution of 0.593, so that's correct. And again, I've done some of these calculations for some of the images, but just not all of them. And so what I'm going to simply do is I'm going to copy and paste all of this information, and I'm going to add another column where I can either say that it checks out, all the numbers check out, or there's some discrepancies. So probably put like some either yes, pass, or no. So far it's passing. The next step would then to be check the vertical resolution in the physical height of the image. I kind of went away for a second there, guys. All right. So to do this, all I have to do now is just change the angular difference calculation, which in this case is going to be for the angular difference in latitude for this image. So 26.21 minus 26. All right. But honestly, something tells me that the problems I'm having with my analysis are probably not associated with how I've written my code. To get to this point, I had to make some modifications to our database, and I think that that might be where the problem lies. All right, so I can actually get rid of this. So 3,638.8 should be the physical height. So 3638.8, 3638.8, that's correct. And if I divide this by the physical height, 8599, I should get a pixel resolution of 0.42 meters per pixel. 316, 316, yeah, that's right. So this image checks out as far as how it's doing the calculation. And quite honestly, as far as how it calculates the physical height, physical width, and pixel resolutions along the horizontal and vertical directions, if it's doing it correctly for this image, it should be doing it correctly for every single image. So really all I would need to do is make sure that it's actually retrieving the information from our database correctly. So that should cut down a lot of the work. So really all I need to do is just verify the first 1, 2, 3, 4, 5, 6 columns. Or the first 7 columns, excluding the first column because the first column is the image name. But then again, something tells me that if it's retrieving the information correctly for the first image, it should be doing the exact same retrieval method for the other images. But there might be the case where it's like, I don't know, truncating the numbers incorrectly or something. I doubt that, but honestly, then that's actually a problem in itself, because if my analysis code is working correctly, that means that the problem lies with the information I'm retrieving from our database. And like I stated before, I've made some attempts at making a few corrections, but I might have to go back in and make more corrections. All right. So to check these values, all I would have to do is go back to our database, change the image name that I want to search for. It'll bring it up. And luckily, because I've already copied and pasted it to my my text editor here, I can compare them directly instead of having to like switch back and forth between tabs. That's a good point. Well, if I made typos in the code, um, I think it would show up as a syntax error. The worst things you can have in your code are like logic errors. You'd have to track those down. Which is the reason why I try to make sure I put like safeguards within my code to indicate whether or not things are not working properly. How does one understand the world of code? Oh man. Um, that's actually a very complicated question for me. Actually, I'm not really a master. I'm like this. Whenever I code, I know what works for me, but if I was ever asked to actually teach a coding class, it might be initially difficult. I would have to read up on all the proper ways of coding and stuff like that. But generally, if I'm looking at someone else's code and as long as they can tell me generally what the code should do, um, I guess the key things I want to know would be, what are the inputs? That is, what information do I need to pass to the code to make it work properly? What are the outputs? What do I expect to get out from the code? Which part of your source code holds the main function? And right now, I'm kind of talking in terms of C++ coding, because I don't think a main function is common with every single programming language. And of course, this all relies on you being able to know um, some of the basic coding. I'm coming to I have a lack of words right now. You need to know like how a for loop operates, how loops operate, how if then statements operate. Okay. All right. So again, I'm pretty sure that this is all working out correctly. So 8599, good. 4670, good. 26.22, 26.09, 3.65, 3.56. In all honesty, I think that my code's doing exactly what I want it to do. Hmm. This is hmm. Oh, that is so cool. I think it's really cool when someone can like jump back and forth between different languages. I've gotten so used to coding in C++ that if I had to jump to another language that I've written something in, well, I can understand C++ really well. Um, I can understand IDL fairly well. The numbers look like IP addresses. So so basically what we're seeing here, it depends on where you're looking on the screen because I have a lot of stuff here. With the bottom window, that is my terminal window. It's outputting information that I've requested from my analysis code. But then I have a much smaller window here that begins with the words calculations for incidence angle analysis. And basically what I'm doing is I'm copying and pasting the information that's in my terminal window and I'm verifying that it's coming out correctly. So each of these is a single line. So this would be the first line where I verified the values and put a yes or maybe I should put like a pass to indicate that all the values are correct. This was the second line, and basically I've verified that all those values are also correct. And so I'm just going through each line that was output by my code and verifying that the numbers are correct. But quite honestly, I think that I'm going to put a pass for all these lines. I used Mathematica a very, very, very long time ago in undergrad. I think I used it once. And if I were to look at some Mathematica code now, it would probably be difficult for me to understand initially. All right, let's go ahead and verify this next line. Yeah, Python is becoming more and more popular every day. And I know Big J codes in Python. A350 3841. Well, you don't have to code as of right now. Yeah, I'm coding on my MacBook Pro right now, but you don't have to code on a MacBook. You can code on a Windows machine as well. Just download the proper applications and you should be able to do it. In all honesty, the more and more I look at this, the more and more I just feel like this. I for the most part know that this is correct. Um, let's see, 236. Oh, that's the sun angle. 26.09, 26.22, 3.55, 3.64. And it does that calculation exactly the same every single time. So that is a pass. All right, let's move on to the next one. Peppermint Linux? Is this a new type of Linux distribution, Peppermint? I haven't heard of it. But then again, I haven't really been keeping up with the different Linux distributions. In all honesty, I mean, in undergrad, I that using Windows was like what I did every single day. That was what my computer was. It was a Windows machine. But when my first experience with Linux changed my whole perspective on, operating systems. I quickly fell in love with, working with Linux machines. And it's free, exactly. The operating system is free. Huh. All right. So 112. Let's go back here. Let's go ahead and copy and paste the entire line. Well, I think, and I would have to strongly agree with you, Mark. Um, and it might be because of the fact that maybe it offers Windows offers applications that I'm assuming this has to be the case that Windows. Well, no, I can't say that now, right? I was going to say that Windows offers applications that other operating systems don't probably offer, but I don't know if that's truly the case. Or maybe that's the situation that it's more user friendly, as Peter stated, quote unquote user friendly versus other operating systems. Um, all right, and yeah, I'm gonna say that it's no coincidence that the very first four images I've checked out have passed because I don't think this issues with my code. In all honesty, guys, I've tried so many different things to try to fix this. And my brain is drawing blanks on exactly how to go about fix, making any sort of change that would completely fix it. Which is the reason why I've asked Pamela to help me out here. In the event that she wants to be able to review these numbers, I'm just going to comment out this section. And I can always run it during our meeting. But something tells me that this is not the problem with the code. Hmm. Oh wow, there's a lot more people here than I expected actually. I don't know if it's truly showing if it's actually 19 people here. But for those of you who have like stayed around and just listened to me ramble about the problems with my code, thank you. I stated this earlier, but science is fun, but it's extremely fun when things work the way in which you intend for them to work. And kind of right now I'm at the moment of like I'm very frustrated because in all honesty, everything I feel that I've done should work. And the only conclusion I can draw based off of all the checks that I've done, I mean, I've done visualizations of the values that my code is calculating, as well as like manually check the numbers. And my only conclusion is that there's something wrong with the data itself that my code's importing. In the past, let's say that I've made a few changes to the data. Nothing that's of course, going to be like scientifically unethical, but hmm. All right. Well, guys, again, thank you guys for like hanging around with me, and I really did enjoy the side conversation about all the different operating systems and how Linux is in my personal opinion better than Windows. But all right, guys, I'm going to go ahead and shut down the stream, and I will be back on Friday after Pamela or Andre's daily news update on what's new in astronomy. And so I look forward to that day, and hopefully by then everything here will be fixed, and at the very least I can give an update saying, "Hey, things are working now," and show that things are working. That would make my life so much happier and easier because then I'll be that much more closer to being able to produce the paper I'm trying to get out of this analysis. All right, guys. Again, thank you for tuning in and sticking with me, and I will see you guys on Friday after daily news after the daily news stream with Pamela or Andres at 12 o'clock p.m. Central Time. All right, guys. Bye.